Hmm. Okay. Okay, so we were back on that one problem. Do you remember which one it was?
Nice.
Let's see if I can. Was it in 2 or 1?
It's one. That was last problem.
The last one?
Yeah.
Oh yeah, okay. Okay, now I remember. Okay, let's do standard view. And it says well, the picture shows that as well. So 500 pounds to be resolved along AB and AC. So you could look at it like this. Really doesn't matter which way I draw it. I can draw it the wrong way, and it will be okay. I'll call this one FB, and I'll call this one FC. Understanding that I'm not using the A, but some people might say FAC, but I'm just going to use C. And so really, what you've got to have is FB plus FC has got to be equal to the F here. Now, okay, so he tells us this, but what is he asking? He wants if the component of force along AC is required to be that directed from A to C, determine the angle theta of the 500 pound force. Now he's telling me directed from A to C. Oh, I did that. I just did it by accident. Directed from A to C. I did it by accident. It's okay. So this will be 500. Okay, so I'm going to break each of these components down. Maybe I'll scroll this down and use the white space on top of that. Oh, that's as much as I can scroll it down. So I'll just use this space over here, starting at the very top. So I'll start with F, and it's going to be 500 cosine theta I. The reason being, I'm going to break it down to the component going this way and the component going that way. And this is 500 cosine whatever that theta is. This one's going to be 500 sine of theta, whatever that theta is. So I'm going to break them into the x and y component. And plus 500 sine of theta j. So I got that broken into its components. Here it is along the x. Here it is along the y. And so now I'm going to go back over here and erase these and then work on the C and then the A. And what I might do, I might move the FC over, but actually the FC is pretty easy because if I look at FC, I have a component going down and a component going to the right. This is 45 degrees. I know that the cosine of 45 degrees is equal to the sine of 45 degrees, which is equal to 1 over square root of 2. So, with that in mind, I'm going to list this force as FC equaling to the magnitude of FC, which I'm just going to call it FC without a bar and without the things, over square root of 2, this looks funny, moving in the x direction, plus, but it's going in the minus direction. It's going down, so it needs to be a minus FC, the value of FC, in J. So I broke it into its two components. So now I'm going to go back and work on the FB. And maybe what I'll do with the FB is I'll make it a little bit longer, just so I can have this, and I'll say it goes to this direction, and it goes up here. So, since this is 60, and that's the angle, so if I just move this line to here, then that's the same line. So this would be FB cosine of 60. This would be your FB, and this would be FB sine of 60. And this is supposed to be a rectangle, but I guess if you look at it from a distance, it kind of does look like a rectangle. So FB is just going to be FB, the magnitude. So this FB, I'm writing it, so this is the magnitude of that vector. So FB cosine of 60i is going to the right. Going up, FB sine of 60j. Now I know this equation right here has got to be, this is what he wants me to do. Okay, so now let's look at the thing he wants over here. If the component of the force acting along AC is required to be 330. Okay, AC, that's this one. This is required. Okay, if the component acting along AC is required. Oh, wait, directed, okay. So I think that's required. I'm sorry. That is required of the magnitude. So if the component force acting is required to be 330 is equal to FC, directed from A to C, and we already did that, determine the angle of the 500 pound force. So now, if that's the case, I can go in here, 330, and go in here, and 330. Now, if you look through all this, what you'll find is now I have a couple of unknowns, two of them. Mainly that is unknown, and FB is unknown. So now let me try to put this equation together with this, and we'll see the two equations that we get in order to answer the two unknowns. So we know, and I guess I'm going to rewrite it. You got that, right? So what I'm going to do is take the x. So what I'm going to do, I'm going to go up. I'm going to take the x as an equation. I'm going to go up and take the y as an equation. So this will be an equation, this will form an equation. So what I'm going to do is I'm going to do the components of the I first. On the left side, I got to put 500 or 550? 500. And that's got to equal to this plus that. So 330 over square root of 2 plus FB cosine 60. Now if I look at the J equation, I'm looking at this one. So I got to put on the left side sine theta. And then I got to do I'll do this one first because it's positive. Minus 330 over square root of 2. Now if you stare at this long enough, you'll realize a couple of things. You've got, I forget the name, what they call it, transcendental equation or something like that. And from that, from the transcendental equation, you get kind of stuck. It's going to be a little bit difficult because you got an FB here and an FB here. So it's going to take a little bit of effort to solve this. I'm going to try something. I think that little mouse, let's move the little mouse thing out of the way. I'm going to try something. I don't know if it's going to work, but let's see. Oops, we can't solve this equation, but we will be able to soon. Okay, so how would you solve this? One way is to put these two on top of each other. So 500 tangent of theta. That's not going to get you anywhere though. The only way I can see is if you multiply, let's try this. The whole thing times sine of 60, the whole thing times cosine of 60. However, that's not going to be good because I need to do a minus somewhere. So I'm going to do a minus here. And then add them together. So I took this 500 cosine minus and then sine of 60. Okay, so I'm taking this times this and this times this. And I'll go ahead and take this times this and it'll be 500 . Okay, so that's these two equal to, and then the left hand side, the right hand side, that times that, times a minus and a sine of 60. Now when I multiply this times this, and this times this, and add them together, I don't get a term. Now I've eliminated things to the degree that I've got a sine and cosine together. And let's see if I can figure that out, because what I've got is okay, so I take the 500 and I guess I can move it to the other side and I'll say sine theta cosine of 60 minus cosine of theta sine of 60 equals to all this minus 330 over square root of 2, but now I have the sine plus the cosine. And divide that by 500. Have you ever seen this? Does that look familiar? Let me see if I can't bring up an extra screen on that one, but I can on this one. Let's look at it's either going to be I don't remember which one. It's going to be either sine or cosine of this plus 60 or this minus 60. I don't remember. So if you look at the thing, you'll see that. Let's see if I can find the trig identities. Okay, there's maybe, oh gosh, that's really tiny. Oh gosh, that's even tinier. Where are the list of trigonometry? Okay, let's try that one. Okay, this is not so tiny. Okay, this is all great. I need to see the sum multipliers. There we go, right there. Okay, so if you look, okay, this is kind of invading part of the board. Maybe right there. So what do we have? We have, first of all, we have a minus. And then, if we have a minus, do we have double signs? No. We have this one. And so, if you look at that, then that's alpha minus beta. So the question is, what is alpha here? And so first of all, it's going to be sine. The alpha is the one that is the sine on the positive component. So it'd be theta, and then it's going to be minus 60 equals 2. So from there, you should be able to complete this out, because what you do is you take the arc sine of that, which will be a number. You'll get a theta minus a 60. You'll move the 60 to the other side, and that'll be the number that you'll get from the theta. So this angle sum and difference identities is what it's called. I'll just remember it's an identity. So, but that's another question. Let me see if now, what would it do if I did this? Okay, equals 2. Okay. So they were claiming that they would eventually be able to solve this. Let's see if I can do it in this form. Okay. Oh shoot, let's see. Got to back way up enough so that the shadow might goof it some. Here I could do my hat. Oh, I think I got it in here. Okay, did I get the right thing? 500. Okay, so what he's showing me up as, he has an approximate. This is funny. 0.356047 plus 2k pi. And the k means you get repeated. If you put in k equals 0 or k1 or 2, but he also has another one which is 4.87994 plus 2k pi. And the same thing applies. And I think, okay, this is equivalent, I think, of 20.4 degrees and 279.6 degrees. So it depends on how you, I mean, it's just solving the theta, the angle. So actually, technically, it does know how to do it, but he didn't know that intermediate step. So see, not all this software can do all that. There's I don't know what the 1 is doing in the middle of that. Maybe the 1 is to indicate that long side. But this is how he comes up with those things. So these come from that thing. And then you got an angle, oh, sorry, not an angle, but you got what? Huh, it says it just says it's going to snow this evening. That's not. So you got this triangle. This triangle sits in the midst of this triangle, that triangle, and that triangle. So if you stare at it and look through the whole thing, you'll realize that this box, which is a rectangle, you can get all four of those from that box. Okay, so then the other question, what was the other question? Okay, where did it go? There it is. Part B, compute the magnitude of the force along AB. So once you come up with your angle, which would be here, which is probably going to be the 20 for me, 0.4, then you can take it and put it in here and put it in here. And then what you can do is, it's kind of up to you, but you could take this one or you could take this one and solve it. So if you put in 500, let's just say I didn't make a mistake and say it was cosine of 20.4 degrees. That has got to equal to 330 over square root of 2 plus FB cosine of 60. And so all you're looking for now is FB, because that's your magnitude. That would be your 500 cosine of 20.4 minus the 330 over square root of 2, and then divided by the cosine of 60. That would get your value, which is your magnitude of your FB, which is this one. And notice, okay, I assumed it in that direction, which is fine, but if I flipped it over, he's only looking for the magnitude. He's not looking for a sign on there. So my guess is you put in a positive no matter what there. So did that all make sense to a certain degree? And in the last hour, I couldn't get the thing to stream, but now I've got it working. I had to reboot the computer. So if there's something that's kind of off, you can go look at the stream. It should be. It used to send me notifications, and sometimes it does, and sometimes it doesn't. I don't know. Sometimes it's reliable, sometimes it's not. Let me look. Yeah, we're live. There it is. So it's got the little red thing. That's the problem we're looking at. So are y'all good? If you're good, I may go ahead into, okay, but if I do, I gotta go to here. Those were out of. Okay, and then I gotta go to the table of contents. I'm gonna find where I was, because it should have a little dark. Okay, position vectors. So before I go on, I just want to double check. So that was the last problem, wasn't it? 224. That I don't need anymore. How do I get back to, all assignments? Let's look at homework 2, which that should be available now. Is there any questions in that yet, or is that, should I address those next week, since it's Friday today? If you don't have any questions, I mean, I'll address them when you have the questions, because it's kind of better if you have the questions to know what questions to ask. So if you don't mind, maybe I'll just go ahead and do pick up the thing with the position vectors. Okay, I click that. And talk about this. This is kind of a weird nomenclature, but let me do it. And I may just do a problem, and that might show us what we need to know. So maybe let's do that. And we'll go through the sequence. And as a matter of fact, maybe instead of looking at what's A and what's B and all that sort of stuff, instead of doing this, I'm just going to go find a problem and work it, because sometimes it's easier to do that. So let's see, what does he have for a problem here? I mean, we can always look at his and then, I guess that's okay. Let's see if we can find one a little bit more complicated. Yeah, that's a good one. Let's just kind of do that. So you can go down Main Street and see this. If you go look on Main Street, you'll see the little roof covers, and there's a cable. Sometimes one cable, this looks like it has two, and it says that. It says one has actually 100 newtons and the other has a 120. And then he's going to want you to find the resultant of them. So let me just go through this just by using this information on this plot on the left. So the first thing is I can draw a vector from A all the way to B. And so what I'll do is I'll call that vector AB. Now if you look at it, there's 2 or 3 or 4 different ways you can do this, but the way I like to do it is just do a step. You can do a step, you can do the X, then the Y and the Z, or you can do any sort of combination. So what I'm going to do is walk straight down till I hit this axis. Now he's put an axis here of X and a Y, and luckily this is still up on the board, so there's your Z. So I have walked down 4 meters. I've walked south 4 meters down in the Z direction. So that's the first walk I've done. Then I'm going to walk out here to B. And when I walk out to B, I'm walking towards the X. I'm walking 4 meters towards the X, and that's it. I didn't walk anywhere else. So again, I did 2 walks, that one and that one. Now if I want to do A to C vector, trying to draw it. So there's my AC vector. Okay, I walk out to this, and then it looks to me like I'll walk straight back in that direction 2 meters. So I do the same walk along the axis, and then I walk along the positive 2 meters along the J. And those are my 2 vectors. So the thing is walking the axis is a good way. There'll always be some way which you could walk an axis to get there. You may, in this case, I had to walk down Z, and then I, and then J. Or down the Z, then the X, and then the Y. But I did that, and I got those. So now, what I'm going to do is, if you don't mind, I don't think I have it up, but I may have it up, but I don't. I'm going to bring up MATLAB, and I'm going to put these in, and I'm going to talk about them, but I'm going to do the math in the MATLAB. And we'll see why in a minute. So I'm just going to use the letter AB for, and the AC for my vectors. And so what I'll do is first one was AB, and I have to remember that when I'm entering this, you know, like I'm going to enter AB equals to, I'm going to put the X component first, then the Y component, and then the Z component. So that's what I'm going to put in first for that one. For AC, I'm going to put in the X component, the Y component, and then the Z component. So I'll have both these vectors in MATLAB in a second or so. And let's see, I wrote them large enough so I can actually see them. So there's my first one. Pretty boring, but 4, 0, minus 4, 4, 0, minus 4. Now I'm going to do this one, and that's going to be called AC. I can use my arrow up, and I'm going to put in a 2, and I'll call it a C. Was it 2? Yeah. So there's my second vector. So I got this vector in 4, 2, minus 4, and I got that one. Now, let me erase this and I'll go back to the picture. But one of the things I want to do first, well, let me go to the picture and describe what I'm doing next. So next thing I'm going to do is I have a vector that goes from A to B, right? But I really just want a unit vector that goes there. So I'll call it unit vector AB, I'm sorry. And this one will be the unit vector AC. And you'll see why we want those in a minute. So if I want this, I guess I'll just call it UAB. And what it'll be is AB divided by the norm of AB. In MATLAB, that norm, if you don't specify it, it's basically the square root. And in this case, for AB, it's going to be 4 squared plus 0 squared plus 4 squared. 4, 0, and 4. And that's what the norm is. It's going to be this, that. Just going to be that. And then you're going to divide each of the coefficients by that. Each of the values by that. So let's just type that in. And I'll call it unit vector AB is going to be equal to AB divided by the norm of AB. And I get a vector which looks like 7071 I plus minus 0.7071, and that's K. So that's the vector. Now, if I want to know the vector of the force, FAB, it is true it's 100 newtons, but it's 100 newtons, and the direction is specified by this unit vector AB. And so if I want to know that FAB, I just multiply 100 times the UAB. Now what I'm going to do before that is I'm going to find UAC. And what you're going to find here is that the vector FAC is going to be equal to 120 times the unit vector in the direction from A to C. So let me find the unit vector AC. Okay, unit vector AC is equal to AC divided by the norm of AC. And there you get some digits that are kind of hard to like quantify, but I'll just go ahead and write them down if I can actually see them. Okay, so it's a little hard for me to see them, but I kind of think I can see them. So the unit vector AC looks like 2/3 I plus 1/3 J minus 2/3 K. Now if you square this, Square that term, you're going to get 4/9. Square this term, you're going to get 1/9. Square that term, you're going to get 4/9. 4 and 4 is 8, 1 is 9, and so the length of this vector is 1. So now you stare at this, the question is, I'm going to use this vector and this vector, and what I'm going to do is I'm going to find FAB in the MATLAB. So what I'll do is I'll just go to the MATLAB and I'll just type that in. So FAB is equal to, now FAB had 100. 100 times unit vector AB, that's the actual vector now. So this vector becomes 70.7107 I minus 70.7107, and that would be the K. And that's the FAB. So there you go. There's your FAB right there. Now the FAC is 120 times unit vector AC, and that's going to end up being, that's interesting, 80, 40, and 80. So FAC is equal to 80 I 40 J and minus 80 K. Now let's see how we did. We hadn't added them together yet, but we will in a second. Or I could just do it real quick. Let's add them together because he's going to want to add them together. So F resultant, FAB plus FAC. So you add these two together and you get a resultant vector of those two forces equaling to 150.7107 I plus 40J minus 150.7107 K. And so those are those two things added together. That's the resultant. Let's now go back. Since I had that there, I'm going to go back and see what he did. So here he started. He started the thing finding RA to B. And then he did RA to C. And he said, well, these two forces are going to end up with a resultant when I add them together. So then he says solution. Okay, so he goes down and he specifies that the directions A, B are specified by forming unit vectors along the cables. They're obtained. The unit vectors are obtained from the two vectors of the cables. And so here's his RAB. Okay, so his RAB was 4I minus 4I minus 4K. He found the length, 5.66. Next thing he does, he takes this and divides by the length. And let's see, that was AB. And so this is what we might come up with, hopefully. Let's roll down. Okay, there he goes. So he comes up with that vector. So he says, I'm going to take this R over RAB. This is the magnitude of the 5.66. This is the vector itself. I'm going to multiply times 100. I get 70.7, which is this, minus 70.7K. So we get the same FAB. That's supposed to be a B, but it doesn't look like a B. So let's see what he does for the next one. It's kind of the same thing, except we end up having to transverse down the 2. I put a 4 there. No, oh, there it is. I'm sorry, 2. 4I minus 4K. and a 2. Okay, so I did okay. RAC, we got that. We ended up with, he puts the thing, which is 4/6, which that was the 2/3. The 2/6, which was the 1/3. And then the 4/6, which was the minus 2/3 that he has there. And the 120, that's the magnitude of the 120. So we get an 80, a 40, and a minus 80. So there's nothing really that fancy or anything like that. So then you go down and you say, here's your answer, and he threw away some digits. I don't think I did. 150.71, he said 151, 40, and then minus 151, and I got 150.71. He just took the 0.7, moved it into 71, and 71 and 80, 151. And so I guess that's okay. And so then he draws the vector. I'm not sure how accurate physically that is, but it looks pretty good. To me it does. I think about the J component being out this axis. That first one from A to B has none of that. So the fact that this vector, the blue vector, moved to the right a little bit gives you that 40. And the fact that 151 and 151 are actually the same kind of is indicative of that this is 4 meters and that's 4 meters. So, and I guess that's it. So that's pretty much all this thing is you just transverse down the axis, find the length of the rope, make that vector that is the length of the rope equal to a unit, then multiply times the force in the cable. And that's it. That's all there is to it. There's nothing more fancy than that. In this case, we added 2 together. Sometimes you don't. Like here's one. It doesn't look like you add another one together. Find the force acting on the hook, expressing Cartesian vectors. To me, it looks like this goes out to that point B, and what he's doing here is he's making it a little bit obnoxious for you to find the location B. So you got to draw this vector, find that B. You got your A, and when you find your B, you draw a vector from A to B, but you got to know where B is. And so it's 30 degrees. He's saying this is 4/5. So then you gotta work your way into finding what B is. It's the distance from here out to here, then the distance from here to here, and the distance from here to here. And so you'll have that 30 degrees in there. So you just have to work your way through these. It just takes you a minute. So you can see what he's done here. But here's the picture on the left. Here he's basically walked the axis, so to speak. First he looks like he walked the X, walked out here, and then walked up there. So you got that as far as where B is. Here's where A was, and that came from the drawing here. So now you just have to subtract this from this. You'll have that vector pointing in that direction. And then, when you have that, what do you do next? Okay, so what he's done is he said, here's A, and he put the meters in there too, and then here's B with some meters stuck in there. And then he wrote those down and shrank them down to just numbers. And then you subtract the two of them. And that's the vector that goes from A to B. Well, where did he have it? Okay, from A. Okay, here you go. Vector goes from A to B is this one. He turns it into the unit vector. Okay, now you can multiply times whatever the tension of the cable is. Okay, and then his tension's 750. I guess I missed on that, but And it looks like he's got a tiny little teeny tiny video.
In this video, you'll be able to test your understanding
Man, that's
of being
tiny.
able to establish a Cartesian position vector.
Oh, but it's
and
just
command
tiny on the
establish a
screen.
force vector.
That's weird.
We formulate a unit vector in
Okay,
the
so,
direction
you know,
opposite
these are pretty
46
good.
From this one. So
That looks pretty good,
only
actually.
go 6 meter.
Oh,
This
that's
would-
all the problems we just did.
Whoops.
That's the first one.
Anyway, all the,
Let's see.
well, one of
That's the
first things
second
we-
one. So
we
he
have to
does all
consider-
these. Why did I do it? Yeah, well,
We take the, and we get our answer.
he probably does a better job than I do anyway. Oh, and here's the third one. Okay. Well, so there you go. So it looks tiny, but if you zoom it in, it has high resolution. You can change these in the web. And so they have a container that holds it. It's just they didn't make the container very wide there. So and the next thing we're going to do is dot products, but I may save that for Monday if y'all don't mind. And we already talked about it, but I may go ahead and let you go because I let you go about 5 minutes early, but so we'll do that. In the meantime, I'm going to sit here for a minute. So do y'all have any questions? I guess we'll just pick it up next time. Just do the dot product. And if you got more questions next time, work some of them over the weekend if you got problems with them. Because the dot product we kind of already did. So I could zip through it in 5-10 minutes and then we can use the rest of the time for problems. So go work some of those problems and then see where you are on them. All the videos are tiny like that. But they're decent resolution. Huh. Oh. So if I'm watching this,
Quiz and see if you can get all the questions
force me
correct.
to answer the quiz.
Can A dot B be a negative scalar?
Oh, it stops. Then what do? Do I hit start again? Huh.
No, that's the wrong answer.
So, yeah, I understand the problems, but so I tried many times, but it's not matching the answer to the questions.
Okay.
Yeah.
That one is a very confusing. Let me do that one next time because that one has a lot of attempts at it.
Yeah.
And so if don't worry about running out of attempts. I can delete your attempts so you can go in and get it right.
Yeah.
But if you don't mind, that one creates a lot of problems. Like everybody has trouble with that one.
Yeah.
They may not say they do,
Yeah.
but they do, and there's a lot to that. Which one is that?
So yeah. So I got questions. So index class 3 problems. So.
Oh, okay.
Yeah. So number 10, so number 13, and so today's problem. And
Oh,
16.
okay.
Yeah.
Okay. So yeah, let's do that Monday. Is that okay?
But so this assignment is due today.
Oh,
Yeah.
Don't worry about it. I don't take off anything.
Yeah.
So just it'll still be fine.
Yeah.
So don't worry about that. I can change the due date in a matter of minutes. Would it make you feel better if I change the due date? Here, let's just change the due date. This is for
So can I
one.
send
This
to,
is
so
one.
these questions? So but
Do
can I
it.
send to email so these questions?
Yeah, yeah.
So,
let-
so last time so I sent you before.
Yeah, if you do that, that would be actually great because then I'll know which ones to do.
Yeah.
That'd be.
So I sent email so the 3 questions to.
Okay, so right now
Mm.
it's due date. Is that today?
Yes, today.
Oh, let's make it Tuesday. How about that?
Yeah.
There we go. It's due on Tuesday now.
Mm.
There you go.
Yeah.
So yeah, if you have issues with that, that'd be great if you just clip Send me that, and then I'll just do those.
Mm.
So that would be great.
Yeah.
And then don't get bogged down. Like if you get in one, you're like, oh, I don't get it. Just go on to the other and just send me email about that one. And then we'll work that one the next class period. And then you just keep going. So if you just jump on, if you're done with all of one, don't worry about it. You can jump to homework 2 and start, carving some of those out.
Mm-hmm.
And then that'll give you an idea of what you can ask on homework set
Okay.
2.
Yeah. Yeah, I will send today.
Okay. Yeah, and there are due dates, but they're there, and no points are getting taken off, so it's not a big deal. But I'd appreciate that if you could send me like those, then I'll just come in and do those in whatever the next period is. So that'd be helpful for me too. So what I'll do is intersperse working those with some of the more advanced things, and we'll just keep moving forward.
Okay.
That'd be great.
Okay. Thank you.
Okay, thank you. I don't know why I did not. All right, see ya.